before we start. You may have to edit out some of the things or I haven't started sharing. That's good. All right. Okay, so all right, so let's get started. Today's meeting is really about GitOps. So what I want to do is take a very basic and a simple experiment, just run it first without any GitOps or anything, and take a look at the experiment, and then try the same experiment, the GitOps version of that experiment, and then look at the diff between the two experiments and exactly what was needed to make the GitOps experiment happen. As we know, Iterate is actually a flexible system, so what I'm showing is really one way of doing the things that I'm showing. There are really many ways of accomplishing it, but we will look at this one way. I think the general pattern of being able to do an experiment and based on the result of the experiment, making some changes to your GitHub repo, I think it's a very powerful pattern and it's a very useful pattern, obviously. So that is really the crux of today's discussion. But again, there are many ways to accomplish it. We will see one way of doing it today. Okay, so I'm going to start with this very basic, your first experiment. Incidentally, I'm sharing my screen. Am I audible? Is my screen visible? Is everything looking okay? Or any issues?
Yes, it's visible.
Okay, sounds good. All right, so this is a very simple experiment. I'm going to create a Kubernetes deployment and create an SLO validation experiment. We'll send some traffic to that deployment, collect some built-in metrics, and make a yes or no decision about whether it is working or not. The SLOs are satisfied or not. That's all the experiment is. Underneath the covers, you can switch out this experiment with any other A/B testing experiment or any other fancy experiment. But let's start with a simple experiment. This is what we are going to use to subsequently convert into a GitOps experiment. Okay, so there is some basic setup required. I already did the setup, Kubernetes cluster, I have one, and install Iterate in it, I have one, and I'm using Helm. You will see how it's getting used in a second. I have the Iterate.ctl client, and I have forked the repo, and I've, I haven't done this yet, so let me do that. So username is, this is my GitHub username. Okay, so, and I think I did this also. So we are all good. Now let's go ahead and create our application. As I said, this is a very simple hello world Kubernetes deployment and a service. It can even be a Selden deployment. You can switch out the Kubernetes deployment for a Selden one because obviously you are interested in the Selden deployment. And let's just verify that the app is, actually running. So I'm just going to put forward the service and call the service. Everything is looking good. We are in Hello World version 1.0. There's really only one version in this experiment. We will come to the 2 version and the promotion GitOps in a second, but in this experiment, there is just one version. Let's go ahead and create the Iterate experiment. And there are a few things to notice about this experiment. First of all, we have Helm templated the Iterate experiment. And the reason for this is that I now have an experiment which I can use with really any deployment. This is the sample deployment, of course, that we put together for the tutorial. The experiment itself is a bit more general because, it's asking where should I query this particular deployment. That's the, Helm value that I'm supplying. So you can switch out the sample deployment with an actual deployment. I mean, your application deployment, and you can still do this experiment. Assuming, this is the pattern, this is the experiment pattern that you. So this is the other direction that we are trying to move towards. As much as possible, we want to figure out how to Helm template our experiments so that they really become reusable. I think this reusable pattern is present in a lot of different use cases. But even if you have to make changes, you're making minimal changes to the Helm template rather than having to start from scratch for the entire experiment. So that's where this Helm templating of experiments can help. Either simply reuse a template or make minimal changes to the template and reuse. That's the idea of Helm templating. In this particular case, it's just a simple SLO validation experiment. So Iter8 is going to send requests to this URL inside the cluster, and it's going to decide if the error rate, it wants a 0 error rate, doesn't want any errors. And we are also saying make sure the mean latency is under 50 milliseconds and the tail latency is under 100 milliseconds. And if so, then the experiment is working. That's the application is working. Success. That's what it means. So let's go ahead and take a look at the actual experiment that we deployed. So I'm just doing a Helm get manifest, and this is the manifest. It's a very simple experiment, conformance experiment. At the beginning, it's going to collect metrics by sending queries to this URL, and it's going to check these, validate these SLOs, just as we discussed. That's what the Iterate experiment is going to do. Okay, so we have this iterate.ctl command line, and we can assert that the experiment completed and your application actually won, a winner was found. Let's see. Everything is good. So the application completed and the winner was found. If the application didn't work, you wouldn't have this winner, it wouldn't have been declared as a winner, so you wouldn't have found a winner, but a winner is now found. So let's go ahead, describe the experiment. Again, I'm using the Iterate.ctl command line tool to describe the results of the experiment in a bit more depth. All the SLOs are satisfied, true, true, true. And these are the actual metric values. Mean latency is well under 15 milliseconds. It's 1 millisecond. And so is the tail latency is also well under 100 milliseconds. It's 1.6 milliseconds. So that's all this experiment is. It's a very simple experiment, Kubernetes service. You send some requests, measure latency error rates, and these are built-in metrics of Iter8, and everything is looking nice. So done, success. So let's clean up this experiment. Now,
can I ask a question here?
Yeah, please. Yeah, please.
For the metrics, I saw you have a collect metrics steps. Does it mean the apps need to expose a metrics endpoint in order?
No. So there are a few different ways in which metrics actually, it's a very good question. So there are a few different ways in which metrics collection works in Iterate. The first one, the one that I showed you right now, is a built-in mechanism for collecting metrics. Iterate will send requests. If this is not a metrics endpoint, this is actually the application endpoint. So this is the same endpoint that I used. Sorry, I cleaned up the experiment a bit prematurely, I shouldn't have. But this is the same URL. See, I exposed the URL, and I think I put forward the URL here, and I queried that URL using just a curl, and it gave me back this hello world response. It's the same URL that Iterate is pinging, it's sending requests to, getting responses back, and measuring how well the application is performing in terms of errors and latency. So this is the built-in metrics. Now, obviously, this is not sufficient. For a lot of real-world applications, you have to measure, it's business metrics, or even if you're measuring these types of, system metrics, you need to use some database for reading those values. So that's the other thing. That's where the custom metrics come in. So you don't need to use built-in metrics if it's not sufficient for you. You can use metrics from any REST database. So your metrics can be in any RESTful endpoint. And as part of the experiment, you can include metrics from any query metrics from any RESTful endpoint. The REST endpoints we have documented so far are for Prometheus, New Relic, Sysdig, and Elastic, but these are just examples that we have documented. So others are already asking, for example, for Hive and other types of databases where their metrics are present. As long as you can query the metrics RESTfully using HTTP, you can use it for either validation or A/B testing in an Iterate experiment. That's how the metrics. And there are many examples of Iterate, including certain examples actually, of Iterate querying Prometheus. And there are other examples of Iterate querying New Relic and Sysdig and other things for A/B testing experiments.
I see. Thank you. And regarding the request, so for this one is a simple get. Can we say provide some payload and Iterate experiment can use, or?
Yeah, absolutely, yes. So there is a way to use payloads. And let me just check. People are working on precisely this feature in Iterate, so I want to check what is the status right now. Give me 1 second. We can look at our metrics examples to see if there are, So, this is custom metrics. We're talking about built-in. So maybe this is work under progress. Then I have to get back to you on post APIs. But the answer is yes. Either it's already there or it's coming soon. There's a way for you to use the built-in metrics collection mechanism with, for example, a JSON payload of your choice. There is a way to either do that today or it's coming soon, one of the two. So there are other consumers who are asking for exactly this. Built-in metrics for any CRUD operations. That is the feature that I'm referring to.
Okay, thank you.
Okay. So, that's an action item for us. So we will come back to you definitely with that. Okay, so moving forward with our tutorial, right? So with our second tutorial, we want to do pretty much the same experiment that we just showed now, but we want a GitOps C version promotion flavor. So the candidate application worked, it's a success. Now you want to promote it. You want it to replace your stable version that is running in production. You want the candidate to become the latest stable version. So that is the flavor of the experiment that we want to showcase now. The setup steps are identical to the previous setup step. By the way, this whole thing takes me much longer to describe the experiment and do this presentation, but really this whole thing takes 5 minutes if you actually try it end to end. So do give it a shot at your convenience. It's really easy. So let's try this. Now the scenario that we're going to try is the following. We want to create a stable version of the application, and I want to create a candidate version of the application, both using some manifest available in my GitHub repo, and then create the Iterate experiment. So within the Iterate experiment, I want to collect these built-in metrics for the candidate and ask the question, does the candidate satisfy the SLOs? If the candidate satisfies the SLOs, then we would like Iterate to actually create a PR to promote the candidate. And if it doesn't satisfy the SLOs, then it will simply not create the PR. In this example, it won't create the PR, but you can definitely set up Iterate to send you a notification saying the experiment failed or something else. So all that is also possible. But in the simple experiment, we have this flow: create stable version, create candidate version, create an iterate experiment, and that is going to collect built-in error and latency metrics. Everything works, create a PR to promote the candidate as the latest stable version. That's the idea. Okay, so step one is create stable version. Let's see. Okay, stable version created. This is again your hello world basic deployment. Create candidate version. So you create the candidate version in a candidate environment, of course, and in this case, I am simply going to define my candidate environment as a candidate namespace. That's all. So I'm going to create a namespace and just create the candidate version within that namespace. There is no such requirement that the candidate version has to run in a candidate namespace. It can run within the same namespace as your stable version. It can run maybe even as part of a completely different cluster. So maybe your promotion event is not within production, but your promotion event is actually promoting from a staging cluster to a production cluster. So maybe you want to create a candidate version in a different cluster altogether. All of that is possible. This is a simple example, and in this example, we are just going to use a different namespace to run the candidate version. I should also add, incidentally, this is again the basic case of Kubernetes deployments, but if you're one of the more advanced users trying to do the iterate with KF serving, for example, then the KF serving CRD already provides stable and a candidate version options for you. So within the same resource, you can create both the stable version and the candidate version. I believe Selden deployment does exactly the same. So within the same resource, you can provide two different versions of your application, and both of them can run in parallel. So all those possibilities are available. Again, this is a simple case of Kubernetes service and deployment, so we will just create one in a candidate namespace. Okay, according to this, it's being created. So let's see if it is adapt these instructions to verify that stable and candidate versions are running. So let us verify if it's running. I put forwarded my stable version. Is it running? Yeah, it is running. Now let me put forward the candidate version. As I mentioned, we are creating it in the staging namespace. So start. Yeah, that's also running. So I got 1.0 and 2.0 both running in the Kubernetes cluster in different namespaces. Okay, so now comes our iterate GitOps part of the story, right? So we want iterate to create a pull request at the end of this experiment, saying replace my my stable version with this new candidate version, assuming the candidate is successful. That's what we would like iterate to do. But for iterate to do this, it actually needs some permissions, right? You can't have random things creating PRs against your Git repos. So there needs to be some authentication, and there needs to be something that says, yeah, here is a token or something. Here's a way for you, this agent, to create a GitHub pull request. So we need to enable GitOps with appropriate permissions to be able to create this pull request. Notice that it's not doing a commit. It's still not. You are still going to have the option of being able to verify the pull request and then merge it manually. So there is still that manual intervention that is possible. However, even to create the pull request, some permissions are needed for iterate, and we are going to enable iterate to do so. So let's go back to the setup steps. I think setup steps are okay. So create a personal access token on GitHub. I already went ahead and created it. And there are two things. So if you've created a path in GitHub before, you need the repo permissions and you need the read arg, because read arg permissions are needed pretty much for anything to do in GitHub, and repo permissions are needed to create the pull request. So against a particular repo, so within a particular repo. So actually the repo permissions are not needed for creating the pull request itself, but Iterate is going to do a bit more. It's going to create a branch, push changes to the branch, and then create the PR. And that's why the repo permissions are needed. So repo permissions, read arg. Let's go ahead and grant those permissions to Iterate. So first of all, I need to create a secret with my GitHub token in it. So let's create this gh token environment variable. I want to do this securely. So I think I have a script. Good. So now I have that environment variable gh token that's holding my token. And let's go ahead and create a Kubernetes secret with that token in it. And let's go ahead and give Iterate the permissions it needs to read this token and to use this token. This is just a Kubernetes secret, and this is just me giving permissions to Iterate to read that Kubernetes secret that contains the GitHub token in it. So this is definitely the recommended approach for creating tokens in Kubernetes and surfacing them to Iterate. Okay, so let's go ahead and create the Iterate experiment. So what is this doing now? What is this experiment doing? It's pretty much the same experiment as before, except there are a couple of twists. First of all, it's not the hello.default that Iterate is going to be collecting metrics for. It's hello.staging. That's my candidate. And it's the same criteria that I've said here. Mean latency is 50 milliseconds, error rate is 0, and 95th percentile tail latency is 100 milliseconds. So that is the SLO validation criteria that I've set. Username, I think I set my username correctly. Yeah. And the username will be used. That's the repo. My fork of the Iterate repo is where the PR is going to land. So that's why I need the username to customize the repo. And this is the image. This is the change that we will look into the experiment. This is the new image that needs to be promoted if the experiment turned out to be a success. And we will see how these Helm values are actually baked into the experiment. Okay, so let's go ahead and get the experiment. I think I put it in, yeah, mine is in staging. So this time I created the experiment within that staging namespace. So let's go ahead and take a look. I'm just getting the Helm manifest that we just deployed so that we can look into the experiment. Once again, at the beginning of the experiment, there is a way to collect built-in metrics using GET requests to this URL. But a whole bunch of things are happening when the experiment is actually finishing up, right? So you collect the metrics, you check this SLOs, everything and criteria and everything is looking fantastic, and you are, success. Your candidate version is doing really well. Now we just want to go ahead and change something that is present in our GitHub repo. And how would you do this manually? Forget about Iterate. If you were to do this from your command line, you would do exactly something similar to this. You would clone the repo, and you would say, well, go into that folder, and you would, whatever branch you want to create, you will create that branch. Whatever changes you want to make, in this case, you're just changing, here's how the Helm value is getting used for the new image. So just go ahead and change the image to this new image. and do a commit and do a push. And that is the branch creation part and, pushing to the branch part. And this is the actual PR creation. So Github actually provides a command line utility called GH, which can use to authenticate with GitHub and create a pull request from the branch that you just pushed. And that is the feature that we are using here within the experiment. We're just, creating a branch, pushing to the branch, and creating a pull request off of that branch to the base branch. That's the workflow. Exactly what you would do if you were to do this whole, branch creation and PR creation using command line. That's what we are doing here. There are two key points here. One is, first of all, this whole thing is going to run only if the winner has been found. In this case, it's a conformance experiment. There's only one version. So if that version satisfied all these things, it would be declared as a winner, and the winner would have been found. But if that new version did not satisfy your SLOs, then no winner would have been found. So this thing wouldn't even run. So this whole script is going to run if a winner was found. Otherwise, it's not going to run. That's step one. And step two is this is running in a specific image called, the task runner. Iterate tasks run on an image called the task runner. And the task runner is already preloaded with a lot of these, it's based off of a Debian base image, but it packs with it other command line utilities like Git, like YQ, like GH, and it has other things like Helm, Customize, the typical Kubernetes command line tools that a developer might actually use when using Kubernetes. So the image actually comes, fully packed with these tools, and it's really easy to extend. So if there are other things, if you don't like YQ, you want to use GQ, those are the types of things that are very easy to add to this image, so we can always do that. But in this case, all I needed was, I have a YAML manifest, and I wanted to do some changes to it, assuming we found a winner, and create a PR. So this is the experiment, and let's see the status of the experiment. So we can once again go and do Iterate.ctl. Describe first. Let's first describe. Iterate.ctl. Describe. What happens? So there is a winner. Winner has been found. That's the version, and it's looking good. So this experiment also succeeded. Now, according to the claim here, after the end of the experiment, we should be seeing a PR in my GitHub repo. So let's go take a look. We will go back to the experiment in just a little bit, and the structure of your application just a little bit. But before that, let's just go take a look at the PR, right? So it's at github.com treeumcp, that's my fourth. Okay, so there is a PR. This is the PR created 6 minutes ago. It says treeumcp, but it really was created by the Iterate experiment that I just ran. And let's look at the file changed. It is this file, the actual deployment file. Previously, I was using 1.0 image. Now, the PR actually saying use 2.0 image. So this is the actual PR created by the experiment. And now we can take a closer look at this dir file and the directory, right? Oh, sorry. I'm going to view the file. So this directory just has the deployment and the service, and the deployment is the simplest possible imaginable deployment. Oh, this is the PR. So if you go to the master, it will say 1.0, and in the PR branch, PR fork, it's saying 2.0. So that is the actual diff between the base branch and the head here. of Git. So that's really the long and short of it in terms of, Iterate making the changes to the GitHub repo. Now, a few things I think are obvious, but I will say it anyway. So everything that I showed you in terms of the finished task, you can of course modify it. It doesn't have to be a deployment spec that Iterate is changing. It can be that it is changing, let's say, some other YAML. It can be changing a KF serving inference service. It actually can be changing your homemade. You shared that homemade YAML previously for specifying the candidate version and the stable version. It wasn't even a Kubernetes resource spec. It was merely a YAML spec, which is okay. Iterate can go ahead and change that YAML spec in Git, because as you saw, we're just using YQ. So we're just doing some YAML manipulation as part of this YQ. Anyway, so these are just a few possibilities. Let me pause here, see if there are more questions.
Yeah, that's really interesting. Can we go back to the experiment, YAML?
Yeah, thankfully I didn't clean up anything this time. Experiment YAML. Okay.
All right. Okay. So my first question is what's the language of, or what's the definition of the if, the run, and the with? Is that just part of the experiment CRD?
Yeah, it is part of the experiment CRD. So let's go a little bit deeper into this. So Iterate, as you know, has a notion of tasks. So you can run. Here's the way. Let's take even one more step back, right? So the way to think about an experiment is you have a start action and you have a loop action. In this experiment, there are no loop actions, and you have a finish action. So start, loop, and finish are the three actions. And within an action, you can specify a sequence of tasks, okay? So, and there are many types of tasks you can specify, metrics collection being one of them, readiness checking being another. You don't want to start an experiment until you have a few Kubernetes resources present in the cluster and they are in some ready condition. Notification being another task. In this case, run is actually similar to your GitHub Actions run. So you can, in GitHub Actions, you can specify a run and provide a script as part of your run field, run stanza. Same thing happens here. So you can specify a run, and you can specify any script that you want to run as part of the run stanza. Same idea. Now, the if clause, right? So if clause is for conditional execution of tasks. So Iterate, this is a very recent feature. So Iterate previously had a notion of tasks, but on top of it, now Iterate can also support conditional execution. So you can say, run this task. If you found a winner, you can in fact go a step further. If you have a two-version experiment where you have a baseline and a candidate, you can say, run this task if baseline won, and run that task if candidate won. So you can have different types of conditional executions of these tasks. And based on the outcome of the experiment, you can run whatever you want to run. Previously we had a notion of these tasks with templating, Iterate-based templating as part of it. That is still happening here, but we were kind of felt that we were overusing templating, and it was kind of becoming hairy. Many of the experiments that we were taking to our users was actually getting a little bit hairy with the kind of templates that we were writing. So this is based on actual feedback saying, we need to simplify templating, and this is an attempt to do so. So you can still use templating, but it's actually easier to think of it as conditional execution and say, this happened in the experiment, this is the outcome, do this, that is the outcome, do that. So that's supported now. The if condition, there are right now two conditions that are supported, winner found and candidate won. Those are the two conditions that are supported. Here there's no candidate, there's only one version in this experiment, but in an A/B testing experiment, you will have a baseline and a candidate. In the canary testing experiment, again, you will have a baseline and a canary version, which is the candidate. So if the candidate won't do something, or in this case, just a single version, there was a winner, do something. You can also couple it with the negation. You can say not winner found and do something, or not candidate one, do something else. Under the covers, there is some Go expression evaluation magic that is going on to make these things possible. So there is a Go expression evaluation library that is, making this functionality in the CRD actually work. That's how it's implemented.
Cool. So you've got if one and also with, which takes service account secret.
Yeah, with is for inputs, if is for conditional, and the actual, in the case of run, there is the actual body of the what you want to run itself. Run is it's kind of a catch-all. If you don't have, if you're looking at iterate tasks and you're not finding a task that you have something in mind and none of the tasks are fitting that thing in your mind, you can always, resort to run and just say, here's my script, run it, and here are some variables that you will have to use as part of that. So with right now for run task, I think there is a single input that it supports, which is a secret. So there is a way for you to supply a secret and extract that secret information within a token and use that as part of your GitOps flow.
All right, cool. I was just wondering where you think that the roadmap for this part of Iterate would go, because I could sort of imagine maybe people would want to run arbitrary to Argo pipelines here. So imagine how much do you want to work on this and make it more and more complex?
That's a great question. So I think there. First of all, there are. We don't really like experiments that have hair-splitting shell scripts embedded as part of it, right? So it kind of scares the heck out of people, and they're like, "What? I thought we were doing something declarative here, and here is the whole bunch of shell scripts bringing all 80s glory here." So we don't want that, right? However, I think in this case, the shell scripting is justified, partly because it is a complex task. You want Iterate to do something, and based on the result, create a PR. And we thought quite a bit about, is there a way to abstract out this PR creation process? Everybody's going to have their own twist on what the GitHub repo is going to look like, what their application is going to look like. So flexibility, I think, is going to be required here. So that's why we went with this option. Now, you don't even need a run test, right? There are notification tasks. So if you want to just take this whole complexity out of the Iterate experiment, you don't even need to put it in the Iterate experiment. You can just tell Iterate, finish the experiment, send a notification, and by the way, you can trigger a GitHub Actions workflow using an Iterate notification. So GitHub supports, webhook receivers for GitHub Actions. Iterate supports notifying anything. So you can, with the appropriate secret, you can trigger a GitHub Actions workflow. So you want to say, I want to handle the complexity of changing my repo in the GitHub action. You just finish the experiment and let me know. That is already supported. So that pattern is already there.
Yes, yeah, so you did.
Yeah. I think the second question you were. Yeah, sorry, go ahead. Yeah.
I was just going to say, if you did that, then I suppose the question would be, you've got some stuff you might want to query about Iterate, like winner found. So would there be a case for having like Iterate Python SDK or something? So if you did run a GitHub Actions, you could still talk back to Iterate, because you'd have to know winner found, winner not found.
Right. So remember, the pattern that I just described was about notifications. So you wouldn't necessarily wait for the experiment to complete and then query Iterate. In the notifications, when the experiment completes, there would be a push, right? So Iterate would push a notification and you will know it. Now, there is no Python SDK at the moment to do the query, but of course you can query Iterate using Iterate-CTL or even just using kubectl. The Iterate experiment is declarative, so you can always use kubectl to just find out what is going on in the experiment, query the experiment, and see that is it completed, has the winner found. Iterate.cdl is just a wrapper around kubectl. So it takes a lot of the white queue and all that, gunk out of kubectl, and in fact, you have a simple one-liner to do the same thing. But Iterate experiment is in all its glories available. You can always use kubectl to do the same thing. That's part one. Part two is, I think you also referred to Argo CD in one of your earlier comments, or maybe I misheard you. So.
Yeah, I don't think I was talking about that so much.
Okay, but I will anyway take exploit that opportunity to talk about it. So we just push something to GitHub, and the PR is happening. Okay, so PR is happening. PR is there. I'm not going to merge it, but let's say you merge it. So your GitOps repo actually changed, right? Now you have your environment repo in Git has the version that you want, has the version that you care about. Now, at this point, GitOps operators can kick in, right? So you're modifying a GitHub repo. So obviously, Argo CD, if it is set up to pick up the changes, to act on those changes, it can pick up those changes and make changes to your cluster. So you don't have to do anything at that point if Argo CD or Flux CD or some operator or Jenkins X, whatever you set up. If it's set up to react for changes to your environment repo, then it will just react. So that part of your GitOps pipeline, nothing changes. It's the same as how you would do it manually, except the PR was not created manually, it was created automatically by Iterate. That's the only change. But it's still, the pipeline, the rest of the pipeline doesn't change. It's still whatever you are doing today with Argo CD or Flux CD, you are doing exactly the same thing with this pipeline also. And that pattern continues to hold even if you use GitHub Actions, right? So even if you trigger a notification to GitHub Actions, to GitHub, and that triggered a GitHub Action workflow, that changed your repo. Once again, the same pattern holds. The rest of your GitHub GitOps pipeline continues to be the same, and you can still use Argo CD or Flux CD or whatever you want to use to sync your repo to the cluster.
Yeah, makes sense. I suppose in like a full setup, which was full GitOps, you would have created the experiment by GitOps and the state and the candidate, and then the actual point at the end, if a winner is found, it would in GitOps delete the experiment and delete the candidate and promote the actual stable to the all in one go.
That's where I would draw the line. So this is what you call. I think it really is all about your organizational requirements. That's how I would put it. You see, GitOps is a kind of religion, right? So you can either say every single thing needs to go through my Git repo, and I don't want to see anything in my cluster that's not in my Git repo. So you can go all the way. As a GitOps purist, you can go all the way until you cannot. So logging becomes a nightmare, and debugging becomes a nightmare. So that's when you're going to take a step back and say, hey, come on, can we compromise somewhere? So I would argue, personally, this is my personal, preference, is that the experiment itself is kind of a second-class thing. The thing that I care about is my application. What I want is to make sure my application is stable, my application promotion is working the way it needs to, and nothing is breaking when I move from one version of the application to another. My end users are not affected. The promotion is safe in terms of the end user experience. This is all I care about. So all the good things about GitOps, in terms of when it comes to promoting stuff and ensuring single point of truth, all that, everything is great, but I want to apply all that for my application. This experiment thing is just is an extension of your CI/CD pipeline in some sense. That's how you're actually now beginning to use the Iterate experiment if you're doing all this. So it's somewhere in between a declarative resource and also an extension of your CI/CD pipeline. So yes, you can certainly put the experiment itself as part of the Git repo, let Argo CD sync it, and as part of your finished task, clean up the experiment itself. PR can clean up the experiment also. It's perfectly possible. But I think it's an overkill. I think if you don't need to go all the way, you are better off not going all the way. Just run the experiment. It will push a PR, and your application will be in the state that you care about. What's the worst thing that happens? Let's say you didn't supply a proper secret, and your PR was not created. No big deal. Fix your experiment, run it again, and it will create a new PR, and life will continue. The whole thing about GitOps is that it puts you in control, right? You just created a PR, so you always have the option of deciding to merge or close without merging. So nothing is going to happen without your explicit okay and your permission. So you really are not losing anything by running an experiment that somehow didn't work as you expected. You just need to fix yours. Just like you would fix your CI/CD pipeline, you just fix the experiment and move on. That's all is needed. That's, I think, the way I would think about this whole GitOps business. But as I said, if you're a purist or if your organization has very strict requirements in terms of everything needs to go through Git repo, of course it's possible. You can put this whole GitOps experiment itself in Git. You can put the Helm values in Git. In Argo CD, you can just create a values.yaml file and give a chart repo pointer, and Argo CD will just use that to deploy your experiment also. So you can go the whole way with GitOps. But I mean, if I were to do it, if I was fully in charge of this operation, promotion, I would draw the line at the application in Git and do my own thing for the experiment. Whatever is the most easiest way to push the experiment. That's what I'm trying to say. I'm definitely not saying you should never put it in the repo, but I'm just saying do the most convenient thing when it comes to pushing the experiment. That's all I'm saying.
Yeah, I think it makes sense. I mean, I suppose you could ask your question whether you would ever want to roll back to a state with the experiment or not. So it's just maybe it's cluttering up your Git repo, but yeah, it depends on your organization, I suppose.
Yeah. Cool. You can always query the cluster to find the current state of the experiment and the current state of your resources. That option is always there for you. There are a few ways to do it. In Argo CD, there is a notion of, I forget the name, diffing customization. I remember now. Diffing customization, that's what they call it. So you can just say ignore certain resources or ignore certain changes to certain resources and sync your repo. So maybe you push the experiment once and ignore it afterwards and don't worry about resyncing and all those things. There are a few ways to play this whole thing. But as I mentioned, the whole thing is about convenience. To me, it makes sense that you want a single source of truth for your application. But in this whole experiment, I would view the experiment as somewhere in between a pure declarative resource and an extension of your CI/CD, because you are starting to take on CI/CD tasks as part of the experiment. So that's how I would view it. And you have the option of doing both ways.
Sounds cool.
What we're hearing is that from our OpenShift users, in particular GitOps users, is that it's not all users want everything to go through Git. This is the reaction that we got. Our first intuition, our first instinct was exactly what you said, right? Which is put everything in Git, and the experiment has to go through Git. And then what we heard was a bit of a pushback saying, no, we don't need all that complex. We just want to make sure the application is going through Git. And we know we can roll back the application if necessary or whatever. So this was the feedback that we got from our OpenShift community. And that's why we are kind of structuring it this way.
I have a question regarding the experiment. Looks like relying on the experiment resources itself to say send request. Is there a way, say, I deploy another version of a model and it start receiving, say, live traffic? Can the experiment distinguish the winner of two models based on some existing metrics directly?
Of course. Yeah, of course. That's most of our documentation is in the type of experiment you're talking about. This one is this one is very basic. So I just chose to use the built-in metrics. But the way you would do that is by using metrics from a database. So your application candidate is receiving live traffic, and your application is instrumented, or whatever, your setup is instrumented to send metrics, Prometheus or whatever database, and you would use metrics from those databases in the evaluation.
Okay, yeah. Thank you.
All right, so we have a bigger story that we want to tell with this whole approach. So we got some interest from the CNCF GitOps working group also. So I think next week there will probably be a repetition of this whole thing, so with a little bit more details and the notification based experiments. And also we are working on an Iterate CTL debug experiment. So something went wrong during the experiment. We want to find out more details about what went wrong. So we're working on that CLI also. So that is what we are planning to present next week. This is just a heads up. But it's there is going to be a significant overlap between this community meeting. The next one, definitely we are going to go a little bit all out in terms of our outreach. So that's the plan. So in terms of next steps, and so for the application that you actually showed, for the YAML that you actually showed, I'm wondering how we want to proceed. So first of all, my request is that you take a crack at this tutorial, actually try it out. It should not take more than 5 or 10 minutes. Give it a go and see what you feel, and tell us what you feel, what your reactions, right? That's the first thing. The next thing is maybe we can set up a follow-up call on your application and your homegrown YAML that you actually shared. So perhaps we can see what it means, modify this experiment to use live traffic, to use metrics from actual databases, let's say Prometheus, and use that YAML that matters for your application, and then we can reassess in terms of how that experiment actually looks. Do you think that's a good plan for a subsequent meetup? I mean, not a meetup, a subsequent call.
Yeah, I think that makes sense. But yeah, I just want to let you know because our team is currently focusing on other initiatives, so that's why we might not put a lot of time on this. But I'll sync with my manager and see where we end up. But,
no problem. Yeah.
But I think according to this demo, it looks like it has all the features, so you can do that actually arbitrary things at the final step. So it just works.
Yeah. So that's good. So I will set up something. Yeah, these things always take time, I know. So no rush, but we'll keep the conversation going. And if there are some new requirements that come up, based on your usage patterns, I would be very interested in understanding that also. So the conversation is useful for that perspective also. So, but anyway, so we will follow up with that meeting and we'll see what we can do with the YAML that you already shared. All right, so the call is going to end, but we said this last time, and if you try to kind of ping us offline. So we have a new paper on Iterate. It's a peer-reviewed academic publication accepted, not published yet, accepted at ACM Symposium on Cloud Computing. It's at the intersection of cloud computing and AI/ML. So that's where the conference is. It's joint work with Boston University, and we are going to be presenting it pretty soon, in about a month and a half. So more details on that, we will share that also in the channel. The camera-ready version of that paper is still work in progress, but it's all about banded algorithms. Some of the cool stuff that Iterate plays in. That's what it is. Fancy, nice banded algorithms. Why it's better than doing more ad hoc traffic shifting. That's what the paper is about.
Cool.
Yeah.
That's great. We look forward to reading it.
Yeah. All right. So thank you, everybody, and we will talk again soon.
Thank you.
Cheers.
Yep.
Thanks.